Exponents. That's something like this. This number is written in exponential form. The idea here is that we have two numbers that each mean something pretty different. This 5 is called our exponent. And this 2 is called our base. The idea is that the big number, the base number that's not floating, is the one that will repeat by multiplication. It repeats attached with multiply. This exponent tells the number of times the base, the big number, will repeat. So for instance, 2 to the 5th power. What that means is 2 times 2 times 2, 5 times 2 times 2 times 2 times 2 times 2. That's exactly what it means. And you can evaluate it in parts if you want. You can say, oh, 2 times 2, that's a 4. Bring down the rest. 4 times 2, that's an 8. Bring down the rest. 16. 32. But again, the main idea that I'm trying to get at here isn't what it's equivalent to. It isn't the answer necessarily. It's the fact that another way of representing all of these pieces attached by a multiply is to use an exponent that tells you how many times it was repeated. In fact, the exponential form, or the notation, can be used to represent anything that's repeating. For instance, A times A times A times A. If I wanted to write that in exponential form, I would say, oh look, that's what's repeating, my A. So I'm going to write that there. And the number of times, 1, 2, 3, 4, I'll put that in the air, A to the 4th. So, for example, to make sure we get this, I'm going to say evaluate. Evaluate does actually mean go the whole way, okay? If you ever hear directions or read directions that say write in exponential form or write with exponents, it means, you know what, write it as a power and step away. But if I say evaluate, or if the directions say evaluate, it does mean we want to know that you know exactly what it means by going all the way to the simplest answer that you can get to. So, for example, evaluate 4 to the 3rd power. Well, we know that's equal to 4 times 4 times 4. Again, you just multiply in pieces. 4 times 4 is 16, times 4 is 64. I want to discuss some notation things with you. If you ever see something like this, -6 squared. Note, I guess, as far as when we talk, that with the 2 we can call it squared, versus the others you tend to say, let's see, with the 3 you say cubed, or to the 3rd. With the 4 it's just to the 4th, to the 5th, to the 6th, like that, going up. But here we have -6 squared, or you could say to the 2nd. And what that means is that everything attached to that 2, and here we have parentheses, so we know that everything, the negative and the 6 are attached, gets times by itself. So -6 times -6. Okay, a negative times a negative gives me a positive, and I have a 36. Very cool. I guess anything squared will be positive, won't it? Since by definition, if you have a positive times a positive, you get positive, or a negative times a negative, you get negative. So any kind of combination, whether it had been 4 squared, let's see, that's 4 times 4 equals 16, or whether it had been 3 squared. Notice with those powers of 2 that you are getting positive numbers, regardless of what's inside. With the negatives, not so much. I mean, with the odd powers, not so much. I'll let you play with that more to explore that. But generally, the rule of thumb is if it's even, you're getting a positive answer. If it's odd, you're getting a negative answer. And it's just because of how it works with the two negatives and two positives being multiplied give you a positive. But then when they're opposite, you get a negative. Something I want you to note, though, that being said, is that there is a big difference in the way a problem can be written. Here with my negative 6 squared, notice negative 6 was in parentheses. So all of that was being repeated. I could have written it differently, though. I could have written negative 6 squared like that, without parentheses. The first thing that you're interested in here is squaring the 6. And without parentheses, it's only the number that's connected to that 2. So what this means is 6 times 6. And then, of course, you have a negative that was out front. 6 times 6 is 36. And that negative, since it wasn't repeated, it just comes straight down. You get a negative 36. So I want you to note very carefully that parentheses do make a big difference in the meaning of what's being squared. If there's no parentheses, you are just squaring what's attached. If there's parentheses, everything inside is being squared. Let's try 2 more examples with these exponentials. Actually, I guess we'll do 3. But first, we'll just do kind of a basic one that explores more what I just told you. Negative 3 squared times 5 squared. And once again, I'm going to say, you know what? Evaluate this. Find me a number that this symbolizes. When I'm squaring this right here, that negative is not in parentheses. So actually, I just have 3 times 3. Times, and then of course right here I've got a 5 times 5. And I have a negative that's just going to follow us down. 3 times 3 gives me 9 times 5 times 5. 9 times 5, that's 45 times 5. And 45 times 5 is a 225. And that negative just comes down every time. I mean, had it made you happy, you could have put it on that 3 and multiplied it through, but either way, you'll get the same answer. You're going to get a negative answer in front. So I say just bring the thing down and don't deal with it through each step. Okay, so here we have negative 2/3 cubed. So notice in parentheses, all of this stuff is going to be repeated 3 times. So what we could do is write negative 2/3 times negative 2/3 times negative 2/3. And then go across the top. Let's see, negative 2 times a negative 2 gives me, what is that, a positive 4? Then we still have another negative 2 right there, times negative 2. So across the top we get negative 8. And across the bottom we get 3 times 3 times 3. So let's see, 3 times 3 is 9, times 3 is 27. So we get negative 8 over 27. Notice something for me though. You can write these fractions out and work across the top and the bottom. That's fine. That's literally what it means. But because we have an exponent over something that's just division, and actually this works for just division or just multiplication, I can actually share this like this. I can share that exponent onto both the numerator and the denominator. I could have said, hey, this is the same thing as negative 2 cubed over 3 cubed, which would still give me negative 8 over 27. That's something that for right now isn't too important, but that's going to become important later, so I want you now to go ahead and start seeing that pattern. Notice that you can write these out, or that you can share that power when it's a simple problem where there's only a divide, and I'll tell you for future reference, or if there's other things like a multiply. Okay, good. One more example in this exponents section. If you had decimal stuff, so let's say you have negative 4 times 7/10 squared. This is the same thing as negative 4 times 0.7 times 0.7. I guess I could write parentheses to make it look prettier for you if that bugs you, but it's the same thing. With multiplication, you can do things in any order you want. I'll be teaching you very shortly, though, that order of ops does give priority to that exponent. So just for kicks, even though these are all multiplications and we're safe to do whatever, I'm going to go ahead and multiply these two together first. I'm going to go ahead and find out what 7/10 squared is. Again, reflecting on the multiplication of decimals that we went back over in the first part of this section, 1.2, part 1. We say 7 times 7 is 49. 7 times 0 is nothing, plus 4 is 4. And if you'd like, just for kicks, you're welcome to say 0 times 7, 0 times 0, and share that 0. You didn't have to, though, since it was a 0. I was just showing you in case. Now I'm going to add. I have two decimals to the right, two numbers to the right of my decimals, so I'm going to move that decimal over 2 places, and I get 0.49. So over here I'll come back and write 0.49. This was my side work, which I sometimes give you a thought bubble to contain so it's cleaner. Or if I were you, I would put it on a separate sheet of paper when you're doing your own problems. But I have 49 hundredths, or 0.49, however you like to think of it, times -4. So once again, multiply, however's comfortable to you. I personally like to write longer numbers on top, and with decimals, guess what? It doesn't matter. So I'm going to write this number because it's more lengthy on top and the 4 on bottom. That way I have less to kind of share with each step. So 4 times 9, let's see, that gives me a 36. 4 times 4 is 16, 17, 18, 19. 4 times 0 is 0, plus 1 is 1. And we have 2 decimal places here for the 4 and the 9. So I'll move this one over 2, and I have 1.96, or 1 and 96 hundredths. Remember, since I had a negative and a positive, this answer is negative, so that's when I put that negative on there. Okay, that's it for exponents.